All right, so we're going to take a look at the 1.6 homework, the product rule, the quotient rule. In our quotient rule, we need to identify our numerator and denominator. Again, knowing that the derivative of u divided by v is equal to v du minus u dv all over v squared. Or as I talked about, low d high minus high d low all over low. In this case, it is definitely a little bit more obvious, unlike the product rule, what your u value and your v value are. I still took the time to label each and to label their derivatives. So, number one, I pick my u value, x squared minus 3, my v value, x squared minus 4. They each have a derivative of 2x, and I start setting up my quotient rule. I've got v du minus u dv all over v squared. From there, I've got to do a little bit of multiplication to get my simplifying. I distribute 2x to my first term. Be very careful distributing your negative. Notice I end up with plus 6x after distributing the 2x to x squared minus 3, not minus 6x. From there, I combine like terms, end up with my answer. As discussed in class, it is extremely uncommon for anything to simplify it when you're doing the quotient rule, so don't start canceling things out without being, absolutely certain. So number 2, again, I picked my u value, I found its derivative, I picked my v value, its derivative. This one's definitely a little bit on the higher end of the amount of work I would expect you to do, but again, I start setting up my quotient rule, low d high minus high d low all over low. Had to do quite a bit of multiplying. So 6x times x squared got me 6x cubed. 6x times negative 9 minus 54x. 4 times x squared. And then 4 times 9. Negative 9, Again, keep an eye on distributing this negative. So I did 2x times 3x squared, distributed the negative and made it negative 6x cubed. 2x times 4x is 8x squared, distributed the negative to make it minus 8x squared. 2x times negative 3 is negative 6, but I distributed the negative to make that plus 6x. Combine your like terms, and you have your final answer. Excuse me, the numerator on this one is factorable, but again, we don't need to. Now, number 7 is the special case that we would have discussed in class. Since it's a monomial in the denominator, a single term in the denominator, or another way of saying it, there's no addition or subtraction in the denominator, we can actually break this up into 3 separate pieces, simplify, and then find our derivative. Now, you could use the quotient rule in this problem. You would actually have to do some simplifying. It's one of the rare cases something would simplify. So I recommend taking the time to break it into the 3 separate values, reduce, and then find your derivative. When we get to what's called the antiderivative in chapter 2, you're going to see that this approach that I take where I split everything up is absolutely necessary. So it's a good practice to get in now. Number 9, some trig functions. Again, I've taken the time to label my u and v values, label their derivatives. I've got my low d high minus my high d low all over low. Distributed my negative cosine x and the negative from the subtraction here to get plus tangent x cosine x plus 5 cosine x. And once again, it is extremely uncommon for something to simplify, so we've got our answer. Number 10, again, I labeled u and du, v and dv. I've got low d high minus high d low all over low. Now, there is some simplification that can be done in this one using trig identities, but again, I'm not expecting that you use trig identities. Number 12, again, I took the time to label u and du, v and dv. I've got my low d high minus high d low all over low. And after doing a little bit of multiplication, there really isn't much more that can be done in this problem. Now, number 20 is actually the exact same equation from number 1, so I just went back to number 1 and got my derivative. Like we've discussed, if we're writing the equation of a tangent line, it's the exact same process every single time. The only thing that changes is the level of difficulty or the rule used to find the derivative. In this case, the rule was the quotient rule. It doesn't change that we plug into the original function to get our y value. It doesn't change that we would have taken our derivative, that we would have substituted into our derivative to get our slope, and that we then could use those things to write the equation of our tangent line. All right, I hope this helps. If it didn't, definitely feel free to ask questions in class, and I'll see you soon.